myself Vasakiran Biradar. Today we will be discussing about chapter 1 real numbers, that is class 10th concept. What do you mean by real numbers? In earlier class, that is in class 9th, we have studied what is number system, that is natural numbers, whole numbers, rational numbers, irrational numbers. So real number is a combination of both the rational and irrational numbers. Then what is rational number and what is irrational numbers? Rational numbers means which can be written in the form of a p by q. Which can be written in the form of p by q. For example, 2 by 3, 3 by 2, 2 by 1, 3 by 1. Why 2 by 1 and 3 by 1? 2 can be written as 2 by 1, 3 can be written as 3 by 1. These are also irrational numbers. Whereas irrational numbers, example, root 2, root 3, 5, so on. These are the irrational numbers. Here in chapter 1 real numbers, we will be studying about prime factorization, LCM, HCF, to prove composite numbers, to prove the irrationality, some application of LCM and HCF. So let's begin the chapter with the prime factorization. Let us begin the chapter with the prime factorization first. What is prime factorization? Converting the given number into a prime factors, that is 420. 420 factors are 2 2s are 2 1s are 0. Next 2 1s are 0 as it is 5. Next 3 table, 3 3s are 3 5s are 5 7s are 7 1s are. Now all are prime numbers. 2 is prime, 3 is prime, 5 is prime, 7 is prime. Converting the given question in terms of a prime factorization is known as prime factorization. That is 420 can be written as 2 square into 3 into 5 into 7. Why I have taken here 2 power 2? How many times 2 is there? 2 times. Then 2 power 2. 3 is 1 time, 3 power 1. 5, 7 as it is. This is the prime factorization of the given question, that is 420. Now next concept is to find LCM and HCF. Find LCM and HCF of 404 and 96. We need to find the LCM and HCF of 404 and 96. First we will be going through the prime factorization of 404 and prime factorization of 96 separately. Prime factorization of 404 is, here we need to check the unit digit. If unit digit is even, then it is divisible by 2. If unit digit is not even, then it is not divisible by 2. Next 2 2s are 0 2, 2 1s are 0 1. Next 101. 101 is a prime number, so it can be written as 101 into 101. Next 96. 2 4s are 8, 2 8s are 16, 2 2s are 2 4s are 2 1s are 2 2s are 2 6s are 2 3s are 3 1s are. These are the prime factors of 404 and 96. Let us write separately. 404 can be written as 2 square into 101. 96 can be written as 1 2 3 4 5, 2 power 5 into 3. Now to find LCM, I will be writing the different numbers in both the terms. That is 2 is different, 101 is different, 3 is different. Other than this, any number is there? No. So 2, 101 and 3 are the different numbers. Next 2 highest power is 5, 101 highest power is 1, 3 highest power is 1. So LCM will be 2 power 5 into 101 into 3. In the same way, HCF will be common thing in both the terms. That is 2 is common, 2 is common. Write down 2 first. Then lowest power of 2 is 2. So 2 power 2 is 4. This is the HCF of the given question 404 and 96. Calculate LCM, that is multiply 2 power 5 into 101 into 3. Next question is, explain why 7 into 11 into 13 plus 13 are composite numbers. For this one, we need to check which number is common. The common number is 13, then I can write 7 into 11 plus 1. 13 as it is, 7 into 11 is 77 plus 1. 13 as it is, 77 plus 1 is 78. Now 13 is a prime number. Convert 72 in terms of a prime factors. 78 can be written as 2 3s are 2 9s are. Next 3 table. 3 1s are 3 3s are. 13 is prime, so 13 1s are 13. 13 into 2 into 3 into 13. Since these can be written as the product of primes, therefore I can say that 7 into 11 into 13 plus 13 is a composite number. Why this is composite number? Because we have written the given number in terms of a product of primes by the fundamental theorem of arithmetic. It is given that if it is can be written in the form of a product of primes, then it is a composite number. Next concept is LCM into HCF equal to A into B. For example, if I know the LCM of two numbers, that is 18, if they given the HCF of two number is 4, if they given one number, that is 2, and we need to find other number, then I can solve by B equal to 18 into 4 divided by 2. 2 ones are 2, 2s are. B equal to 18 2s is 36. So other number is 36. The most important formula of first chapter will be LCM into HCF equal to A into B. Today we will be discussing some of the main problems that are asked in the Cbse board exams or state board exams. HCF of 306 into 657 equal to 9. Find LCM. Here HCF they are given you, two numbers they are given you, we need to find the LCM, then therefore LCM into HCF equal to A into B. ಯಾವಾಗ ನಿಮಗೆ two numbers ಕೊಡ್ತಾರೆ LCM or HCF they are given you, we need to find one more number, then we can use the formula HCF into LCM equal to A into B. LCM they are given, LCM we need to find as it is, HCF they are given you 9. One number is 306, other number is 657, then LCM equal to 306 into 657 divided by 9. Cancellation, 3 3s are 3, 1 0 2s are. Next 3 1s are 3 3s are 9. Next 3 4s are 12. So LCM will be 34 into 657. 34 into 657 is 22338. 22338. This is how we can find the LCM. Or whenever two number is given or one LCM is given, then we can find HCF. Whenever they are given you LCM, HCF, one number is given, we need to find other number, then also we can use the same formula. Next question is, can 6 power n or 12 power n can end with the digit 0? For this one, let us take the prime factorization first. 6 can be written as 2 3s are 3 1s are. Then I can write 6 power n equal to 2 into 3 whole power n, 2 power n into 3 power n. First we need to understand that to end with the digit 0, prime factorization should contain 2 and 5 both. Then only it can end with digit 0. For example, if it is the number 10, then 2 5s are 5 1s are. The prime factorization contains both 2 and 5. Here it can end with digit 0. So to end with the digit 0, the compulsory part is it should be a factor of both 2 and 5. Therefore, it cannot end with the digit 0 because it is not a factor of 5. The next main concept is very important concept. It may be asked for 3 marks, 2 marks, or sometimes for 5 marks also. Prove that root 3 is irrational, or it may be root 5, or it may be root 7, but concept will be the same. To prove that root 3 is irrational, let us assume that root 3 is rational. let us assume root 3 is rational. Here what do you mean by rational numbers? Rational numbers are those numbers which can be written in the form of p by q, that is root 3 equal to p by q. What about p and q? Here p and q does not have any common factors. P and q does not have any common factor. What do you mean by this? For example, 2p by 2q. Here 2 is common. That is why I am saying that p and q does not have any common factor. Then here if it is only 2, here there is no common factors in this way. Next, squaring on both sides. On squaring on both sides, we will get root 3 whole square equal to p square by q square. Let it be this equation 1. Now next, square root get cancels. 3 equal to p square by q square equal to p square by 3. By theorem, I can say that if 3 is dividing p square, then I can say 3 will divide p also. Let it be equation number 2. If 3 divides p square, then 3 will divide p also. What I am saying, if 3 is dividing p square, then by the theorem I can say 3 will divide p also. Let n equal to p by 3, then 3n equal to p. Equation 3. P value I got 3n. Substitute p value in equation number 2. Q square equal to 3n whole square divided by 3. Next, q square equal to 3n whole square is 9n square divided by 3. 3 ones are 3 3s are. Q square equal to 3n square. Take 3 to the left hand side. It will be in the division. Q square by 3 equal to n square. Again by the theorem, if 3 is dividing q square, then what shall I say? Then 3 will divide q also. If 3 divides q square, then 3 will divide q also. That is, let m equal to q by 3. 3m equal to q. Now substitute p value and q value in equation number 1. Therefore, root 3 equal to 3n divided by 3m. See here. Now I got 3 as a common factor, but initially I assumed that p and q does not have common factor, but finally I got common factor. Then I can say that our assumption is wrong. For contradiction, it contradicts our assumption that p and q does not have any common factor. Therefore, I can say that root 3 is an irrational number. This is very important concept. Listen here from this one. Root 3 equal to p by q. P and q does not have any common factors. Squaring on both sides, root 3 whole square equal to p square by q square. 3 equal to p square by q square. Q square as it is p square by 3. If 3 is dividing p square, then 3 will divide p also. P value I got 3m. Same as it is, q value we got 3m. So substituting in the given equation, 3 by 3m. So 3 is common. This is our contradiction is wrong. Then I can say root 3 is an irrational number. Next question is, 3 bells ring at an interval of 6, 12 and 18 minutes. 3 bells are ringing at intervals of 6, 12 and 18 minutes. If all 3 bells rang at 6 am, if all the 3 bells rang at 6 am, when will they ring together again? Cbse 2023 question. Listen here. 3 bells are there. 3 bells are there. They will ring intervals at 6 minutes, 12 minutes, 18 minutes respectively. All together they rang at 6 a.m. They are asking you when will they ring again. For example, like this is clock related question. Whenever clock related question, circle related question, traffic signal related question, running track questions, these are the questions that here we will be finding the LCM of the given numbers. That is LCM of 6, 12 and 18. To find the LCM, first we will be taking out the prime factorization. 2 3s are 3 1s are 2 6s are 2 3s are 3 1s are 2 9s are 3 3s are 3 1s are. So factors of 6 are 2 into 3. Factors of 12 are 2 square into 3. Factors of 18 are 2 into 3 square. For LCM, what you will do? Write down the different numbers. That is 2 is different, 3 is different. Any other number is there? No. So 2 and 3 are the different numbers. Next check 2's highest power is 2. 3 highest power is 2. So LCM will be 2 power 2 is 4. 3 power 3 is 9. 9 4s are 36. What is 36? 36 minutes. Therefore, I can say that at 6 a.m. 36 minutes, these alarms will ring again together. Thank you.